start looking at graphically what we can think about with functions, why a graph is considered a function, and that intervals of increasing and decreasing. So this is what 85 looked like. It gave us the function f of t equals 1 over t. So the important thing to remember is that we have to use the function and plug things into the function. So it asks us to find f of t minus f of 1 all over t minus 1. So a difference quotient has this pattern where you're subtracting two types of functions or two pieces of a function on the numerator, and then the denominator, you're going to have something else in it. Sometimes it's just a t. In this case, it's that quantity t minus 1. But a difference quotient has this form where you have something minus something and then divided by something in the denominator. When you use the difference quotient, we need to take that first part, f of t, and replace f of t with its equation. So instead of having f of t in the problem, I'm replacing it with whatever f of t is equal to, because my goal is to use the function. So f of t is 1 over t. So I'm taking this out because it just says f of t, and I'm replacing it with the equation, whatever f of t is equal to. So then we have a minus sign, and then the next part says f of 1. Well, the number in the parentheses replaces the variable in my equation. My variable is a t, so I'm replacing the t with a 1. So I have a 1 on the top and a 1 on the bottom, and I'm going to keep it as a fraction. So I took out f of t, and I replaced it with its equation, whatever it's equal to. And then I have that subtraction sign because it says subtract f of 1. Well, if I was evaluating f of 1, I would take that 1 value and replace t with the 1. That's what it says when you have a number in the parentheses. The bottom part of this fraction doesn't have an f with it. It just says t minus 1. So that means I cannot apply it or substitute it into the function. I just have to keep it as the expression t minus 1. So this is what your first step should look like. You're really substituting. So I'm substituting things in place of the original difference quotient. So it still looks like a difference quotient. I have something minus something divided by t minus 1. Questions? All right, now we have to start simplifying. So we applied the function to the difference quotient. Now we have to start simplifying. And if I look at this numerator, there are really two fractions here. I have 1 over t minus 1 over 1. Brenna, when we have fractions, two separate fractions, what do you usually do with two separate fractions?
You can find the least common denominator.
Yeah, we have to find the least common denominator. And Brenna, if the one on the left has a t, the one on the right also needs
To have a t as well.
Yeah, it needs a t as well. So the common denominator is going to be t. They both need to have a t. So whatever the one on the left has, I need the one on the right to have that same thing. So I need to multiply both the values by t. So if I combine my numerator together, I have a 1 and then I have a minus t. The goal of a common denominator is for me to be able to combine the two together because they have now the same denominator. They're both t. So my numerator here becomes 1 minus t over the common denominator of t. And then I still have another denominator. I still have that t minus 1. This is called a complex fraction. It's from last year, section 8.5. A fraction within a fraction makes it complex. But not really. We don't have to have it complex. All right, so if you look at this new expression, so all I did here was we simplified the numerator. Brenna told us to find a common denominator of t, and then we just combined those two fractions together. Our goal is to continue to simplify. Peter, if you look at the top part, this 1 minus t, what do you think we could do with that 1 minus t?
Could you take out a -1?
Yeah, we could take out a -1. So if I want to flip that around to make the variable positive, I could factor out a -1, and now it becomes t minus 1 divided by t, and then I have this other big fraction bar. That's my main fraction bar, and then I have t minus 1. So I have a fraction on the top. I have a fraction in the numerator. And then I have this big fraction bar. So this is my fraction bar right here. Go away. There we go. This is my big fraction bar. That's the main fraction bar. And then in the denominator, we have t minus 1. I'm just going to make that into a fraction as well, so that I'm looking at a fraction bar, and then another fraction. Does anybody remember from last year how you can simplify this complex fraction?
Do the t minus 1s cancel out?
Why do they cancel out, Peter?
Because they're both in the numerator of the
Yeah,
fraction.
they're both in the numerator of the fraction. So I have the same quantity in the numerator of the numerator, and I have the same quantity in the numerator of the denominator. Crazy complex fraction. If they're the same, then they cancel. So wipe those out. Swish, swish, they're gone. Peter, what do you have left?
-1 over t.
-1 over t. Questions? The hardest part about this class, and I will tell you this from the beginning, is that it requires you to remember everything from last year. And that's going to be the hardest part about calculus. Calc was the first time that really I got tripped up in math. And at this point it's like 22 years ago, but that's okay. But it was so hard because the sheer quantity of concepts you have to remember to apply to the next thing that you're learning. And that's the crappy thing about math. It requires you to remember so much stuff, and algebraic concepts and trig concepts and geometry concepts, and continue to remember that and apply it. And I think that's the most difficult part. You're going to get the new stuff. It's remembering the old stuff that's really tricky. And that's what, when I took calculus in high school, that was the first thing that just started to trip me up, is just remembering. I got the calc part. It was remembering the pre-calc and the algebra to use the calc concepts. Any questions? So again, look at your 86. 86 is very similar, and I have the solution worked out for 86 as well. So check that out again if you didn't get to already. Are there questions? All right, so today we are going to continue to talk about functions. So we're still working with functions, but we're going to kind of switch it over to the graphical part. So we're going to rely some on the graph of it. What does the shape of the graph or the function look like? Why is the graph a function? You will need a calculator, so if you haven't grabbed one, see if you can rummage around your desk and find your calculator, because we're going to be trying to remember how to get max and mins from the calculator. In your packet, we're looking at page 11, section 1.3, and we will do most of this section today. We'll have a little bit left to go over tomorrow, just a very minimal part. And then tomorrow, we're just going to kind of practice domain and range, practice evaluating functions. Little quiz on Monday. So on page 11, we're looking at the graphs of the functions for this section 1.3. And if you look at the example, we have a graph. Kind of looks like a portion of a parabola. My curve was supposed to look a little better, but I feel like I graphed this thing so many times and I still couldn't get it to curve right for me. So this is what it is. But we're asked to use the graph to find the domain, the range, and then part B says f of -1 and f of 2. So let's do A and C first. Let's see if we can get the domain and the range of the graph. I always use a D for domain. Remember, the domain would be the x values of the function. So moving from left to right, looking at the graph on the left, moving to the right. How far does the graph spread apart for the x values? That's our domain. Caden, can you describe the domain and interval notation of our graph?
Would it be bracket -1 and then 4 with a parenthesis?
All right, that's perfect. Why did you say bracket and then parenthesis around the 4?
Because it's hitting -1, but it doesn't quite hit 4.
Yeah, what kind of symbol is that the value of x equals 4?
An open circle.
Open circle, yeah. So that open circle means that point isn't there. It's going to get really close to it, but it doesn't exist in the graph. Nice job, Caden. So again, moving from left to right, looking at the left value, moving to the value far right. Oops. So we're looking at that value and then looking at the other one. That would be that horizontal distance. That's really what domain describes. All right, we're going to skip B and we're going to go to C, and we're going to find the range. The range would be the y values. When you look at the y values, we need to go from the bottom all the way to the top. So you're looking at like the min versus the max, the lowest point on the graph we're given versus the highest point on the graph that we're given. That becomes our range. Gianna, what would the range be of this graph?
It's bracket -5 to 4 with a bracket.
Nice. And they both get brackets because?
They both have closed circles on the point.
Yeah. So that point at the top of the parabola-ish figure looks like it could be the vertex. It's a point. So again, you're going from the lowest to the highest point. We don't want the middle of the graph. We want that vertical spread of the graph. All right, the last part here that I skipped, part B, says we want to find f of -1 and f of 2. So I want to find f of -1 and I want to find f of 2. We don't have an equation. That's what we did yesterday. We used the function, we used the expression, we evaluated it by plugging this number in for x. Well, I don't have an equation to plug it in for. How would I use the graph to find f of -1? So what do I look for on the graph if I'm trying to find f of -1? Think about what the -1 represents. Jack, what variable does the -1 represent when it's in function notation?
X.
Okay. So if x is -1, what are we trying to find?
Y.
Y. So what is the y value when x is -1?
-5.
-5. So I have x. I'm trying to find its matching y value so that it becomes a coordinate. So this is really my y. So I'm looking up x in the graph. I'm finding the y value. So if I go to x2, where x is 2, this is where x is 2, I'm finding its y value in the graph, and that would be 4. So I could really write them as an ordered pair, the point -1, 5 and the point 2, 4. So when you're evaluating using a graph, you're finding the number in the parentheses, that's x, and then you're just attaching that to a y value in your graph. So go to where x is 1, or x is -1, or x is 4, and find the matching y value. Any questions? All right, so the next thing we have here is a little refresher of the vertical line test. So yesterday we talked about equations being functions, and on Monday we talked about equations being functions Tuesday. And we said an equation is a function because each x has one y, or a relation is a function when each x is paired with exactly one y value. What's the vertical line test do? Jeremy, do you remember what the vertical line test does?
It tests to see if one x value has more than one y value.
Yeah. So this is a graphical test. So Jeremy, how does it work? Do you remember, Jeremy, what you're looking for when you do this vertical line test? So if I draw vertical lines, we want to make sure that each vertical line only passes through your graph once for it to be a function.
Oh, I'm sorry. Was I muted?
Yeah, it's okay. Yes, you were muted. It's all right. Is that what you said, Jeremy? Something like that?
Yeah, I just forgot to unmute.
That's all right. So essentially, the vertical line test is a test to determine if a graph is a function. When you draw those vertical lines, they must pass through the graph once for the graph to be a function. And I have those vertical lines drawn in the graph that was given as an example. If it passes through a graph more than once, then it's not a function because the x value has two y's. So a little refresher on the vertical line test. The next group here of terms that we have talks about increasing and decreasing functions. So when you have a graph can have intervals where the graph goes up or where the graph goes down. So we're going to make a little graph here. And we'll actually graph a function that looks something like this. So functions can have different parts to it. A function can have an increasing portion. It could have a decreasing portion. When we describe the section of the graph, we use intervals defined by x. And that's the important part. So we're using interval notation. We're no longer using inequalities, but they're defined by the x values. Because when you look at something that's increasing, you're looking at something that's going up. But we're going to define that by the horizontal distance where the graph is increasing. So it increases from left to right. I'm describing that distance from left to right. So if I look at the graph that I have drawn, this portion on the right, that's the portion that's increasing. It's going up. So here's my increasing interval. I'm just going to write INC. So from left to right, it's going up. The decreasing part even though this has a little arrow showing it's going up to infinity, the graph is actually moving down from left to right. So the portion on the left here, oops, erase the whole thing. Is decreasing. So when you think of increasing versus decreasing, it must be from left to right. So we have to increase from left to right. We have to decrease from left to right. And I'm going to describe that portion horizontally. What's the horizontal distance defined by x? If it's in the middle of my graph right here, that little portion in the middle, it's not increasing or decreasing. What do you call something if it's not increasing or decreasing? What do we say about that line? If it doesn't increase, it doesn't decrease. It is, begins with a C. Constant. So not only can graphs increase or decrease, but they may also be constant as well, which means they have no change. There's no rise in the graph. They're just increasing, or I'm sorry, they're just remaining constant. So if you look at the graph below, we're going to see if we can find the intervals where the graph is increasing from left to right or decreasing from left to right. Now remember, you start on the left like you read a book on the left, and you move to the right. And we're going to describe that interval using interval notation and using the x values, that horizontal distance where the graph is increasing from the left to the right. So if I look at my graph, we're going to start with the increasing part. How many sections of this graph are going up? How many sections are increasing from left to right?
2.
2. So we have the portion on the left that's increasing, and we have the portion on the right that's increasing. We need to describe those two pieces using an interval defined by x. So how far to the left would it start? Like, where does it start on the left side of the graph? And as it moves to the right, where's the last place that it would stop increasing? That's what we kind of need to think about. So I know that this is going to continue to go down to negative infinity, but it's increasing or moving up until that point. And then at that point, it then decides to go down. Can somebody using interval notation and defining it by x describe that interval? So how would we describe the interval that's increasing from left to right? Peter, what do you think?
I have bracket -5 and then -1 bracket.
Okay, so because there's a little arrow on it, it does continue to go forever. So I know.
So would it be negative infinity?
Yes, it would be negative infinity.
Okay.
Yep. And then you said -1, correct?
Yep.
Yeah, okay. And we know infinity gets a parenthesis. And then he said a bracket around -1. And I'm going to say he's pretty much correct, except that -1, we're going to talk about right down below, but that's the highest point of the graph. That value is called a turning point. Literally, the graph turns at that point. The turning point is not included in the interval that's increasing and decreasing because it's the highest point on the graph. So it increases up into that point, up next to that point, almost at that point, but the max, the highest point on the graph, is its own point by itself. It's not included in the interval of increasing. So I'm going to put a parenthesis around it. So it increases all the way up into that point, but not including the point. So Peter, if you look at the next interval that increases, can you give me that interval that's increasing on the right-hand side?
Would it be in a parenthesis 1 and then infinity?
Exactly. So the little arrow on it means it goes on forever and ever to the right. The x value, that's the trickiest part. We're not looking at the y, we're describing the horizontal distance. So these numbers he's giving me are the x values. So at the x value of 1, it begins going up. At the x value of -1, it stops increasing. So we're describing it moving from left to right because that's how an increasing function works. Questions? So that leaves us with the little portion in the middle, and that portion is going down instead of going up. And again, it's in between those two values. So it's in between my x value of -1 and +1. That's where it's decreasing or going down from left to right. But I'm not including the points because those are points. It's the maximum or the minimum value. It's the point where it changes. So a point is not part of or included in the interval. Questions? So we have one more concept, and then we're going to look at the calculator and see if we can find this information in the calculator. The last concept we're going to talk about today is a relative max or min, generally referred to just a max or a min. So I'm going to draw a little graph again. So the word relative max or min means it's the highest or lowest value, depending if it's a max or a min. In a curve of a graph. Essentially, it's the highest or lowest point compared to the points that are around it. So an actual maximum, this graph is going to infinity. That would be the actual maximum value of the graph. That's the highest value of the graph. But a relative max or a relative min is the highest or lowest value when it's compared to the points that are surrounding it, which is going to be in that curve of the function. There can be multiple maximum or minimum values. There can be multiple relative max or min values. So if I'm looking for a maximum, I'm finding the highest point of the curve. We consider this a max. It's called a relative max, but that word relative gets dropped many times. The highest point of the curve is the max. The highest point around or surrounding the other values. The minimum of the graph, well, this is the lowest point compared to the points around it. Over here is a second minimum. It's the lowest point compared to the points around it. One is not more minimum than the other in terms of the word minimum. Yes, I know one point is lower than the other, but they're both considered minimum values when you compare them to the points around them. So here is a min, and over here is a min. So you can have multiple maximum or minimum values. You're comparing it to the values that surround that point. And again, it's called a relative max because it's relative within the graph. Technically, the max in this graph is infinity. There would be no min. I guess the min would be technically the lowest of the minimum values, but we call them the relative max or the min. So what I'd like you to do is to take out your calculator, and I'd like you to graph this function. And then I want you to sketch the graph in your notes. And then we'll see if we can review how to find the relative max and the relative min in the calculator. And I'm going to pull up my calculator as well. I'm just making a sketch. The reason we need the max and the min values is because at the max and the min, that's our turning point of the graph. So that's where it stops increasing or it stops decreasing. So it goes to that minimum or it goes to that maximum value, and then it no longer increases or decreases from that portion. So from last year, using the calculator, how do I find a max or min value in the calculator?
You hit second trace.
Yeah, so go to second trace. And then, Peter, which one do you want to find first?
We'll go with minimum.
Minimum. So we hit number 3. There's my little blinking buddy. So your little blinking cursor needs to be on the left side of the minimum value. So you need to go to where it looks like the lowest point is. Left bound means it needs to be to the left of it. You hit enter. You move your little blinking buddy to the right side of it, and you hit enter. Remember, you do nothing with guess, you just hit enter one more time. And it shows that my minimum value is at negative 0.58 and negative 0.38. We'll use 2 decimal places. So that means the interval stops decreasing at that value, and it turns to an increasing interval. So then if I want to find the maximum, I go back and I do second trace. We want number 4, the maximum this time. I need to kind of move my little blinking cursor so that it's close to the max. So if you ask the calculator to find a max, the cursor needs to be near the max. And if there are 2 maximum values, then you have to do this twice. And you always have to be in that area because that's the definition of a relative max or a min. The highest or lowest point compared to the points around it. And so I can see that this min or maximum value is the exact opposite of my min. They're both positive this time. This graph actually has symmetry, which we'll talk about tomorrow. Questions? So before we leave, I'm going to take this example. I already have it graphed on my page. All right, so this is what it looks like in my little picture that I drew. Can somebody give me the interval of increasing of this graph? So thinking about what it means for you to have an interval of increasing. An increasing function. So which interval or where would this function be increasing? Darby, do you think you can give me the interval that would be increasing in my function?
Would it be would you do the minimum point, which would be negative 0.58 to positive infinity?
So it's going to go from 0.58, but then it's going to stop at the maximum point. So what's the x value?
So then it would just be 0.58.
Exactly. So we're using x values because we're describing the horizontal distance that it's taking up on the graph from left to right. Where is it increasing? So from the minimum value of x to the maximum value of x is where it's increasing. That's the part that's going up from left to right. The other 2 parts are going down. So it's going down on the left and it's going down on the right. The increasing part was in the middle. So it would be decreasing from negative infinity to negative 0.58. It stops at that minimum value. And then it's also decreasing at positive 0.58 to positive infinity. Remember, you're using x. So even though, yes, you're saying, but it's going down, yeah, but we're using the x, that horizontal distance. So your homework tonight should be very similar. You're going to have some graphs. You're going to maybe plug in some graphs into the calculator. If it asks you to graph a function and find the max or the min, please make a sketch so that I can see the function that you graphed in your calculator. That's the only way that I know you're graphing it correctly is if you show me a little sketch. Does anyone have questions? So tomorrow we're going to wrap up this section. We'll just quickly go over this even and odd stuff underneath with functions, and then we'll do a little review. Are there questions? Have a fantastic day.
Thank you. You too.
Thank
you. Have a good one.